Okay, we're going to take a look at even and odd functions. This will help you when graphing your higher ordered polynomials. So if a graph of a function is symmetrical with respect to the y-axis, um, we say that it is an even function. Okay, and so if you look at a down here, that would be an even function because it's symmetrical with the y-axis. You can see that right there, the y-axis basically cuts it in half, right? Um, and so a little bit more of a formal definition, and we'll look at this in a moment, is that for each x in the domain of the function, f of x is equal to f of negative x. And so what we're saying here is, so like if you look right here, if I plug in f of, let's say, 4, f of 4, oops, f of 4 is 7, right? So f of 4 equals 7. And that would be the same thing for f of negative 4. If I plug in f of negative 4, I also get 7 back. So whether I plug in 4 or negative 4, the return values are the same. That's what this is essentially saying, okay? And so we're an even function, even Steven. You get the same thing as long as you plug in opposites. 4, negative 4, I get the same result back. Okay, now let's look at odd functions. If the graph of the function f is symmetrical with respect to the origin, basically that means that there's a 180-degree rotation. We say that it is an odd function. That is, for every x value in the domain of f, f of negative x is equal to the opposite of f of x. Okay, and so once again, we'll talk a little bit about that in just a second. And so, like I said, a was even. An example of an odd function would be c right here, would be c. And so what's going on here is basically whatever you plug in. So for example, for f of 3, I get 4. And so if I plug in f of negative 3, I'll get the opposite. I'll get negative 4 in response. And so that's essentially what that is telling us right here. And so if I plug in if I plug in f of negative 3, I get a negative 4. And if I plug in f of 3, I get positive 4. So the only way I could make those two things equal is by throwing that negative in front right there, in front of the f of x. So f of x, or f of negative x, in this case, f of negative 3 was a negative 4. F of positive 3 is a positive 4, so that negative thrown in front will make the two sides equal. And so basically, wherever you plug in, whatever positive number you plug in, you'll get the opposite result for when you plug in a negative number, and that's going to be your odd function. The other case is going to be neither. And to be honest, most of the polynomials we're going to graph will be neither. But every once in a while, you'll have an even and an odd pop up. And if you know that a function's even, it can make it a little bit easier to graph because you'll know that you're going to get the same values on both sides. Same thing with an odd function. If you know you're dealing with an odd function, it can help you when you're trying to find some extra points. That, if I figure out f of 3, then I'll automatically know what f of negative 3 is. So you'll see that later on when you're trying to graph your polynomials in your homework. So looking at b, that one's going to be neither. Okay, because if you look right here, f of 2, f of negative 2, they're not the same and they're not opposite. If they're the same, you're going to be dealing with even. If they're opposite, then you're going to be dealing with odd. Okay, even Steven, odd opposite. Okay, so let's go ahead and take a look at these next couple graphs down here. So if you look at D, you might be thinking, oh, it's an even function because A was an even function, right? They're both parabolas, but no. Okay, this one's not an even function because the y-axis would have to cut it directly in half, right? And so, like, for example, when I plug in f of 1, I'm not getting the same or the opposite for f of negative 1. I'm not getting either one of those. So that's going to fall into the neither category here. Okay. On E, let's see, what do we think? This one is even Steven, so it's going to be even. Because whether I plug in 1, -1, 2, -2, whatever I plug in, I get the same result, whether it's a positive or negative. Okay? And then F looks a little crazy. This one actually is going to be an odd function. Okay? And the reason why is because when I plug in, let's say 1.5, I get the opposite when I plug in -1.5. Or if I plug in, let's say 4, I'll get the opposite when I plug in -4. Okay? And so odd opposite. Okay, now the last part is trying to figure this out without a picture. Having a picture is pretty easy. Not having a picture, you kind of have to set up a little, do a little algebra to check it. So actually, okay, so I paused the video for a moment so I could bring these down here. So this is when we're dealing with the even function right here. This is going to be for our even, and this is going to be for our odd. Okay, so what I'm going to do is, I'm going to, f of x is this, and so what I'm going to do is I'm going to plug in f of -x and see if it's the same, then it's going to be even. If it comes out actually the opposite, so see, the negative in front signals opposite, right? So if I plug in f of -x, do I get the opposite of the original function in return? That will be an odd. And then once again, neither will be the case for a lot of these. So let's go ahead and try this out. I think it'll make a little bit more sense once we do one of these. So we know what f of x is. F of x is x to x to the third power plus x. So I'm going to plug in f of -x and see what happens here. So if I plug in -x to the third power plus a -x. Okay. So whenever you cube a negative, it's going to stay negative because there's like an understood 1 in front. So when you cube -1, it stays negative, and then x to the third power will just be x to the third power. So I have -x cubed, and then adding a negative is the same thing as just putting -x, right? So that's what f of -x is right there. That's what this is. So if you look here, what happened was when I plugged in -x, I got the complete opposite. Instead of having positive x cubed plus x, I got -x cubed minus x. So I got the complete opposite. So I have the opposite, so it's going to be odd. Okay, let's look at this next one, number 19 here. So once again, what I'm going to do, I know what g of x is. I know what g of x is. This is what g of x is. So if it comes out the exact same when I plug in -x, then it'll be even. If it comes out the complete opposite, then it's going to be odd, or it could be neither. So let's see, g of -x. So I'm going to have -x squared plus -x. Okay. So I'm squaring a negative. Anytime you square a negative, it actually is going to come back positive. So this comes back positive x squared, and then plus a -x. Once again, I can write that as minus x. So now what I have to do is look and see, are they the exact same, or the exact opposite, or neither? And so it actually falls into the neither category because, yeah, the first one's the same, but the second one's the opposite. And so it has to be all or nothing. It's either exactly the same or it's exactly the opposite. And so this one falls into the neither category. Okay, so I think you can probably see where this last one will go then. But let's go ahead and work it. So we know what f of x is. We're given it right here. So we're going to plug in f of -x. So we're going to have -x squared minus negative x to the power of 4, and then a plus 1. Okay, so when you square a negative, it always is going to come back positive. So this is positive x squared. And then whenever anytime you raise anything to an even power, actually, so it's not just squares, it's anytime you have an even exponent in a negative base, it's always going to come back positive. Now be careful, that minus is part of the original equation. So that minus actually does drop down right here. And then the -x to the 4th power does become positive, but you do still have the minus there, which was part of the original function, and then we'll just bring that plus 1 down. And so what you're going to notice is, that's interesting, it's the same, right? It's nothing really changed. Even though I plugged in negative x, I actually have the same function that I began with. So what that's telling me is whether I plug in like 5 or negative 5, I'm going to get the same answer. 10, negative 10, I'll get the same result. So I'll get even results. Okay, so even, this is an even function. Okay, so when you're graphing your polynomials, you'll get this question on your homework asking even, odd, or neither, and that will help you figure out which graph it goes with.